Let's talk about reciprocals of trig functions. Well, as we know, SOHCAHTOA states that if you have a right triangle with angle theta here, then this will be the opposite, this will be adjacent to the angle, and here's 90 degrees. The side that's opposite of 90 degrees, that's called the hypotenuse. And then sine is opposite over hypotenuse, because that's what this says, right? And so on and so on. Sometimes you might need the reciprocal of this. So suppose you know the hypotenuse over opposites value, or let's say you want to know this value rather than opposite of hypotenuse. What do you use? Well, that will be the reciprocal of the sine. And in fact, when you have some complicated formulas that automatically calculates like the height of a building, distance from one point to another, we're going to learn something called solving triangles, where we do these things. And you end up with formulas where the sine will be in the denominator. And sometimes when the sine is in the denominator, it's preferred that you write it in a easier format, and that's when people decide to come up with a new function, which is the reciprocal of the sine function, and they call that cosecant function. And you have similar functions for other ones. So 1 over cosine, which would be, since cosine is adjacent over hypotenuse, it will be hypotenuse over adjacent. And 1 over cosine is called the secant function. And then finally 1 over tangent is called the cotangent function. And as a quick mention, these are very simple ones. You just have to remember this. And just to give you an idea of what to do, so for example, if you want to know cosecant of 90 degrees, well, that's 1 over sine of 90 degrees. And to know the value of sine of 90 degrees, you have to remember the graph of the sine function. Here, 360 degrees is one full period of the sine function. 180 is half, 90 is another half, 270. Let's use a different color. The graph of sine goes like this, right? And it hits the peak at 90 degrees, hits the bottom at 270 degrees. And as we know, these sines and cosine have their peaks of 1 and -1. So sine of 90 degrees is 1. That's what I wanted to say. And rather than trying to remember that sine of 90 degrees is 1, it's better to remember this picture, because people remember pictures much better than numbers. So this is going to be 1 over 1, which is 1. Okay, let's try another one. What about secant of 30 degrees? Okay, that's a tough one. That's 1 over cosine of 30 degrees. Let's draw the cosine graph. Cosine graph, here's 360. 180, 90, 270, and the cosine graph goes like, starts from 1, passes to 0, -1, 0 again, and comes up. Okay, so that's the cosine graph. And cosine of 30 degrees, well, between 0 to 90, there are 3 special angles, right? So it's 1, 2, 3. And we named them small, medium, large. So we see that cosine 30 degrees is the large value. And by small, medium, large, we were using the following nicknames for the values. The following values: 1 over 2, square root of 2 over 2, square root of 3 over 2. They all look like something square root over 2, right? So since this is the largest number of the three, this is what we call the large. So we know that cosine 30 degrees is right equal to 3 over 2. And then you take the reciprocal of that, so it's going to be 2 over square root of 3. And whenever you have a square root in the denominator, you should make it a habit to change it to an integer denominator. So to do that, what you want to do is you multiply right equal 3 top and bottom. So you have this, but right equal 3 times right equal 3 is 3, so that's the value. Okay, so you can do this, and you can also try out some other reciprocals with radians. Yeah, so for tangent, let's try a radian. Tangent of, not tangent, we already know what tangent is. Let's try the cotangent of pi over 6. What's that? Cotangent of pi over 6 would be 1 over tangent of pi over 6. And since pi is 180 degrees, we would get pi over 6 as 180 degrees divided by 6, which is 30 degrees. Okay, so we're trying to look for 1 over tangent of 30 degrees. And I would use the following. Tangent of any angle is sine over cosine. I love this formula. I can never remember the tangent value, so I'm just going to use this. And since you're taking the reciprocal of this, this will be, the reciprocal will be cosine 30 degrees divided by sine 30 degrees. Okay. Now we just did the cosine 30 degrees, which is right equal 3 over 2. That was the large value. And now if you go back to the sine graph, here's the sine graph. Here's 180, here's 90. And between the 0 and 90, you put 3 bars. And the first one's a 30, the next 45, the next one's 60 degrees. Those are the special angles, right? So we have the very first one being the small one. So small, medium, large, easy as 1, 2, 3. Right? We were looking for the easy value, the smallest value, 1 over 2. So 1 over 2 is our sine 30 degrees. And then you multiply 2 top and bottom because you want to simplify the complex fraction. So you get right equal 3 over 1. Anything divided by 1 is just itself, so you get square root of 3. Alright, so that's how you do it. Now let me just finish up this reciprocal with just one example problem that appears a lot. So let's say we know that cosine of some angle theta is equal to 2/3. Okay, just like that. Okay, and theta is in 4th quadrant. Quadrant 4. Now from this, find all other 5 trig values at angle theta. Right? Okay. Solution. Well, let's do the easiest one first. The easiest one is secant theta is the reciprocal of cosine theta, right? So you can just take the reciprocal of this, would be 3 over 2. Done. Very easy. The challenge is the remaining 4. Those are the hard ones. We start by talking about the sine function. How do you get the sine function? Well, you know that sine squared of theta plus cosine squared of theta equals to 1, right? So you get sine squared of theta. This just means cosine of theta and then you square it. Since cosine of theta is 2/3, we know that it's 2/3 squared equals to 1. That's 4/9, and if you subtract 4/9 to the other side, you end up with sine squared of theta equals to 5 over 9. Then you take the square root both sides, you get sine of theta square root of 5 over 9, and you have to be careful whenever you take the square root both sides, you have to use plus or minus. Since we have 2 possible answers for sine theta, we have to determine which one is it. And to do so, just remember that some time ago we did the following. We had this all students take calculus, and in quadrant 4 we know that cosine is positive but sine is negative and tangent is also negative. So that's gonna tell us that we have to take the minus this time. Sine is minus. So let's go back to a regular color. So sine of theta therefore would be square root of 5 over 9 minus, but that's negative square root of 5 over square root of 9, that's 3, so it's negative square root of 5 over 3. That's my sine. Okay, once you have sine, then you're ready to find out the tangent. Tangent of theta would be sine theta over cosine theta. And since sine is negative radical 5 over 3, and cosine is 2/3, now I want to multiply 3 top and bottom to simplify the complex fraction, and that you get square root of 5 divided by 2. Alright. And then we just have the reciprocal. So let's do cotangent theta. What's that? That's reciprocal of this. It's negative 2 over radical 5. Once again, multiply radical 5 top and bottom to simplify the denominator. That just becomes 5. So I rationalize the denominator. And then sine, 1 over sine is cosecant of theta equals to reciprocal of this, so it's negative 3 over radical 5, again multiplied by square root of 5 top and bottom, and you get negative 3 radical 5 over 5. So we found all the other ones. We found the secant, sine, tangent, cotangent, cosecant. So we found everything.